And hello, everyone. I'm Monika Solanki. I am a part of a team at Agrimetrics, which is building a big data platform for the agri-food sector. To start with, I would like to thank the organizers of this event, especially Kathy, for giving me the chance to speak here. It's a pleasure. And also a big thank you to the panelists. We had a great session just before this, and they really made my life quite easy because the important points they have raised are exactly the difficulties Agrimetrics is trying to solve. And even the last question that the audience asked about data interoperability and data sharing, two key things, well, that more or less touches on what I'm going to be talking about today. I'll be talking about how providing meaning to the data that you are going to be maybe selling to other people or exposing as open data, how sending the meaning along with the data goes a really long way in actually helping the sharing of data, because more people can understand what you're talking about, and then data integration, which is also one of the things Kathy raised, that data is driving agriculture in a big way. And what is important is to leverage that to ensure that whatever volumes of data that are being created and exposed are good quality data. This is another point that I think Anne touched upon. It's not just volumes of data are not just the only thing that are important. What's important is that that data is of good quality. And we at Agrimetrics are striving exactly to do this. So today I'll be touching a bit upon how we are using semantics, which is if you like, the context and the meaning for the data, to integrate data and to provide some answers to difficult questions in the agri-food sector. Okay, so who are we? So Agrimetrics is a UK public and commercially funded organization. And the remit, the key goals that we are working towards is to create value from the large volumes of agri-food data that are currently available to us, and in the process provide a data marketplace for the farming sector. So when you're sharing data, security and trust are extremely important. You wouldn't share your data with someone or with an organization if you're not really sure how the data is going to be used and shared further down the line. So we enable companies to safely share their data. And also, if you've put in a lot of effort in and a lot of effort in gathering the data, curating it, making it good quality, you would want to capitalize on that. So you would want to monetize that data. So how you can actually make a decent amount of, let's say, capital or money from the data that you have spent such a huge effort in curating and collecting. On the other hand, there are customers that need this good quality information, and therefore they need a marketplace where they can come and look at the various opportunities available to them, the various options available to them, and make a judicious decision on which would be a good data source for them to tap in. So we have a very nice and robust and scalable architecture, which I will be discussing later on. And this technology that we have, they can be used to basically bring an organization quickly to the forefront of sharing their data, making it available to their own partners in a private sort of data exchange way. And effectively, what this does is it creates a productive and a sustainable ecosystem that accelerates data-driven innovation, something really that the panelists were touching on in the previous session. So, yes, exactly. So Agrimetrics is all about finding data. We basically gather data from a lot of different places, open source, and also we buy data. And we basically provide you with a catalog of that data so that you can basically find the data that you're looking for. You can manage your data. So once you've hosted your data on our platform, you can, for example, update it. You can, in an access control and authenticated way, make it available to your partners. You can even have very fine-grained access control in the sense that you may want parts of your data to be available to certain organizations and individuals and other parts not available. We can do that in a very efficient, safe, and trustful manner. You can monetize your data, like I said, that all the hard work that you have put in curating good quality data, you can monetize that. And more importantly, we enable organizations to get the confidence to expose their data to the outer world without any hesitation on, governance and the maturity assessments that go along with exposing the data. People are not sure whether their data is ready to be available to be made available to people. And what Agrimetrics does is it works with you, it empowers you to get this data enablement feature going with your data. And all of this is done in a way that is very, very aligned with integrating your data, using data models that are very flexible, agile, and that help you to add semantics or meaning to your data, which I'll be talking about later. So what are some of the points that we consider, or which were considered before Agrimetrics decided to, look at this as a problem that the agri-food sector is facing? So if you're a data owner, you might have, issues about exposing your data. You want to expose it, but you're not sure which is the best platform to do that. And you want to basically make your data discoverable. Now, when we talk about monetization, the data owner might want to get a bill for the data usage, control the usage of the data, make your data more attractive. So in the sense that it's nicely presented, it's clean data, it's available in a form that users need, and reduce the maintenance cost. So it's, when a user needs the data is available for them to use. From a data user point of view, what you would like is to find data. If you're looking for a piece of data that can benefit to be with by integration with the data that you have, you want to find a reasonable source of data. Maybe there are more than one sources and you want to make a decision on which is the best source. Find more valuable data. So there is lots of data out there, but some data sets are more valuable than others. How do you decide? Discover relevant related comparable data. So if you're looking for weather, you might be interested in, let's say, the location of the area. You might be interested in the habitats and the natural capital in that area. So this feature of I have something, I need something, and I also need other things related to this something. Easily pull data into my workflow. I have a pipeline set up. I have, let's say, a system that basically pulls my data from 2 or 3 different databases, and I need more data, but I don't want to, spend a lot of time tweaking my pipeline to bring in this more data and then integrate it with the rest of the stuff. So how easy it is going to be for me to pull data from some external source and incorporate it into my workflow. Pay for just the data I need. This is very important because we are living in a big data world. There's lots of data coming in on a daily basis. There is lots of streaming data sources. And I don't want to be tied to, let's say, a particular data provider. I don't want to be tied to a particular format of data. So I want to be flexible about the data that I get, and I want to be able to pay for the data I need. So learn how to get the best value out of your data. Just a second. Okay. Yes. Okay. So what do we have? So what Agrimetrics has created is the Agri-food data marketplace. Now, this data marketplace is a platform to equitably and securely find, manage, and monetize agri-food data. What do we have here? We have a data owner, which could be a person who's got some data that they want to monetize. we have a marketplace, and if we get a chance, definitely in the breakout rooms, but if we get some time during the end of this presentation, I can show you how the data marketplace looks like. So you add the data to the marketplace, decide who can see it and how it can be used. That is totally in your control as a data owner, how the data is exposed. Data value amplified through concept data value amplified through concept-based linking to other data. And this is the important piece that I'll be talking about today, which is about data integration. So effectively, the data that we expose on the Agrimetrics platform comes with the meaning that is intended from an Agrimetrics point of view, and even from a generic point of view. And this meaning enables you to further integrate your data downstream. The data sets, the data pieces, the data points are annotated with relevant semantic concepts that help you make a good decision about whether this particular data set will be suitable to be integrated with the other data sets in your pipeline. There's value delivered back to the, and then coming back to the discovery part, because we have a catalog, you can search through the catalog, you can find the data sets that you're looking for. And if you do decide to go ahead, you don't have to do anything much more than making an API call. So we have different kinds of APIs that provide you in an access control and authenticated way. They provide you access to the data that you are interested in, and also suggest other data sets that might be interesting for you. And what this does is, data users, they get to discover the data owners get to publish their data in a more secure and authenticated way. And in the end, it turns out that the data owner gets value back from the investment that the data owner made by hosting the data on the Agrimetrics platform. So we believe very strongly in fair data, and we strive to make all our data sets available in a fair way. What fair means for us is you can basically find data by searching on the concepts. Let's say you're looking for a field, you're looking for weather, you're looking for rainfall, you're looking for, let's say, solar radiation, you're looking for plant protection products. These are high-level concepts, the top-level concepts, or in domains which are related to agri-tech. And if you were looking for a particular data source, findable for us means in using our catalog, you can explore the data sets that are available to you through the catalog. You can also explore data sets by relationships. So what is the relationship between field and weather? What's the relationship between field and a crop? What's the relationship between a field and a livestock? Because the underlying data model that we use is semantically enriched, therefore you have the capability of basically finding and exploring data sets based on these conceptualizations. Data is accessible through our APIs. You can reuse the data, the published data through our data marketplace. You can expose it to different organizations, different customers at different points in time, depending on who you want to expose it to. And data is interoperable, mostly because of this semantic annotation capability that we have used to enrich our data sets. So it's analysis-ready, bespoke packages of linked data that make it suitable for data scientists. At Agrimetrics, we have, apart from all the work that we've been doing in, getting data, cleaning it, annotating it with semantic information and integrating it, making it available to our end customers, we also have a dedicated data science team, which is using AI and machine learning to do predictions on crops, for example, to basically inform the supply chain on what is the harvest prediction going to be for the next coming years, for the next few years for certain kind of crops. We've been able to actually predict field boundaries as well using these AI and machine learning capabilities. So overall, FAIR provides us a great way of making our data sets available, and we basically believe in FAIR, and we make sure that all the data sets that are exposed to our platform follow this principle. So what sort of data sets are available through the Agrimetrics data platform? This is like a snapshot of our catalog. And we have a wide variety of data for the agri-food sector. So we have data on soil, which is the layers and the textures. We have various data sets related to field, for example, the boundaries, the location, the geospatial information. We have data about crops, weather, natural capital, for example, habitats, water catchments, water bodies. And recently, we've also acquired data sets on plant protection products, which is pesticides. And in the earlier part of Agrimetrics, we've restricted to UK, but no longer. We are going global. We have ingested field boundaries from a lot of different parts of the world. And if I get a chance, I'm going to show you some API queries for those different field boundaries from all over the world. And effectively, as the title of this talk says, what's in a field? If I look at a field, what can I find out about the field? Well, Agrimetrics, through Agrimetrics APIs and query mechanisms, you can find out what crops were grown, for example, in the last 3 years on that field. What's the soil like for that field? What are the weather patterns there? What are the natural capital, which is the habitats, priority and broad, the water catchments surrounding that field. And now with the plant protection products, you can also know which pesticides were sprayed on a field for the last couple of years. So everything really comes to the point where data is integrated in a way that makes sense. And for the consumer of the data, it makes it more intuitive. You get all this information in one place. And this is not to say that you wouldn't be able to do it yourself, but it would take you quite a long time to bring, for a specific field, all these different data sets together, integrate them, and then use a tool like maybe R, MATLAB, maybe Python, Power BI, for example, to draw interesting charts and see the patterns for a specific field. What we do in Agrimetrics is we do all this for you. We make this integrated data available to you in a way that your data scientist can use straight off the box and basically add value to your own products or to your own offerings, which would have been a really difficult task if this integrated data was not available. Some of our data sets are also premium, which are like, for example, if you wanted to know the crop attributes of a field, we go into very minute details of the chlorophyll content, for example, for in a crop, the leaf area index, so on and so forth. Like I said already, we have field boundaries. We have at the moment field boundaries for 2.87 million fields in the UK, and more are coming from all parts of the world. We are reseller for the Airbus Earth observation data. So we make it cheaper for the Airbus satellite Earth observation data to be accessed by someone who would want to use us as a provider of the data rather than going to Airbus. And of course, because this is geospatial data, we have access to the underlying gridded data as well. So although for a field, which is not really a grid, a field has got a specific boundary, we provide the integrated data. But if you were to ask us for the absolutely raw data underlying this integrated data sets, which we use to do the integration, we would be able to provide the raw data as well. That's available too. So overall, it's really a very powerful thing, I would say, for the agri-food sector, where there are large volumes of data, and it's a mammoth task to bring all these data points together, integrate them, and then make sense out of it. So now we come to sort of the more semantic aspects of it. So apart from the real-time data that we have for fields, we also have reference data sets. So for example, what are the different types of soil textures that scientists have found and curated together? What are the habitats? What are the water bodies? What are the different kind of plant species, the varieties within these species, the growth stages, the end uses for a particular crop, and the market options? So what we also do, besides gathering the real-time data, we also curate knowledge, and we make those knowledge graphs available to you again through our catalog and other mechanisms. So apart from having, besides having the knowledge of what's going on in a field at a specific time, I also have access to information like, for example, what are the chemical structures for the chemicals used in plant protection products? What are the resistance action committee codes? What are the formulation types? What we also do is we take de facto or standardized vocabularies or standardized knowledge graphs. For example, QUDT, which is the quantities, units, and dimensions knowledge graph. We take that and we ingest it on our platform. So along with other data sets that you take from us, this is also available to you, and you don't have to, although QUDT is available as a separate source of information, but you get it from us along with all your other data. And a lot of you might be familiar with EPO codes, especially Bayer has done a lot of work in this area. So we have now ingested the EPO codes that are available through the EPO API, and we have integrated it with the crop data on our platform. So really what I'm trying to say is, apart from the real-time data that we have for weather and soil and field and those sort of things which are very necessary for agriculture and agri-tech, we also have knowledge from the sector, and all this is available in totality to you. So now coming back to some applications, and these are just a few, just two. We have actually quite a plethora of applications that we have that we've been working on recently that exploit this integrated data. So for example, we've developed an app for Massive that basically advises farmers on which would be the best point in time in the next 9 days to spray. So this app basically, if there's going to be rainfall, the app informs farmers, not to spray at a specific time, and when would be the best time to spray in the next 9 days. Again, using the linked data and the information that we have that comes to us about rainfall and precipitation, the forecast information that we have in real time. Then we built a natural capital explorer, which was informing local authorities on what the natural capital in a specific area is. So it combines multiple UK data sets linked to biodiversity, water quality, population, and it informs the local authorities on whether when someone comes to them for a planning permission for, let's say, a building or something else, they can quickly look up that area and decide whether that area is suitable for that particular building or something, or a playground, for example. So now, this very quickly going through the architecture. So we have a polystore. Basically, we have a system where we bring in data and we ingest data in a database which is suited for that purpose. So for example, real-time data goes into SQL, some other data which needs to be searched on, for which search results need to come up quickly, we put it in Elasticsearch. And for all the data which is semantic, which comes with annotations, which is self-describing, all of that goes into a triple store or a graph database, as we call it. And we bring this, we have a data lake, we store the raw data, we transform it, we ETL it into these databases, we provide you with APIs, and I'll talk a little bit more about that later on. And we have public, that data is made available to you via API. So it's a really simple architecture, but the core and the strong points about this architecture are the security and the trustworthiness and the access control that goes with it. So you are absolutely sure that whatever you are getting is, or whatever you are wanting to share is shared only with the organization and the individuals that you wanted to share with. So now I come to sort of the binding feature, or the sort of basic foundation underlying this data integration layer we have, and which are ontologies. So I'm quite aware that not all of you are familiar with ontologies. So just to very, very quickly, sort of a very 30-second overview, ontologies are schemas or annotations that give meaning to your data. So they make your data self-describing, and there are several resources on the web that you can find to understand more. But ontologies basically provide you with the mechanism to bring your data sets together, they give meaning to your data, they connect your data by explicitly identifying the relationships, and these ontologies are absolutely the foundation of what we have at Agrimetrics in terms of data sets. So our ontology design is big data driven. Data integration is the primary use case. So not just providing meaning to the data points, but also bringing data sets together. An ontology should help the process of integrating data. It's guided by relevant and well-known external models. We always refer to external models whenever we need something and we don't have it in-house. Mappings to Agrimetrics URI, wherever we have well-known external models, we always make sure that we map it to Agrimetrics URI. We provide lightweight schemas. So if you look into the world of ontologies, you can get very, very expressive, but expressive ontologies do not really help data integration. So we provide lightweight schemas. We avoid expressive features of the modeling language, and we make sure that these ontologies are very well aligned with user-facing APIs, because what an agronomist understands, the terminology, should be reflected in our ontologies, right? So it should be very friendly to the consumer of the data. And this is what we keep in mind.
Monika, can I just ask you to come to a close soon?
Oh, yes, sure. So this is our ontology development life cycle. It basically shows you how you go around developing the ontology. And this is sort of the foundation of building the ontology, which is, using we come up with a data coverage model. And these are typical data coverage models. You can refer to the slides later on. This is and using those data coverage models, then we build this ontology, which is sort of, the data model underlying a particular concept. We have the data point ontology, which is for the real-time data. And this is, again, the geospatial ontology. So once we have all of that, this now gives you an idea of all the different ontologies that we have at Agrimetrics, which are spatio-temporal as well. As I said, we also use external ontologies and services, some of which are listed below. And yes, so these are our APIs. We have a JSON-LD API, which provides you data in a JSON-LD form. And then we also have graphical APIs, GraphQL APIs, that basically allow you to query the data as you go. So you query data as you want it, really. So this is the schema alignment. So our ontologies are very much aligned with our GraphQL schemas. And if anyone wants to see how the GraphQL API works, I'll be very happy to do a demo in the breakout session. As Agrimetrics, how Agrimetrics can provide you value, but we are a source of data, trustworthy data, a mechanism for permission data exchange. You can control who has access to your data. And as a source of expertise, our data scientists can advise you on how to sensibly curate and collect data for your purposes. And that is it from me. Sorry, it might have looked a little bit rushed towards the end, but I think the points that are made in the earlier part of the talk was sort of more driving home the point that we aim to be the data marketplace for the agri-food sector. That's it.